Well, good morning, everybody, and welcome to Ellensburg, Washington, USA. It's a Saturday morning, 11 degrees Fahrenheit outside.
Saturday morning,
Hang on.
11 degrees Fahrenheit outside.
Hang on.
Hang on.
The local time is 8:47 in the morning, and we will begin session B called Crucial Tests with Darrel Cowan at the top of the hour. That's 9 o'clock a.m. Pacific time. Thank you for joining us. Are we 5 by 5? Tom and AZ say 5 by 5. David says 5 by 5. 5 by 5 for you new people means loud and clear. I didn't know that. Talking about the audio and the video. But over the last 2 years, I've learned about 5 by 5, whatever language that is. So I'm so pleased that we are 5 by 5. Let's say hi to a few folks. Because again, we're not starting the program for another 12 minutes or so. Let me slow down the chat here a little bit. Where are you viewing from this morning? Do we have distant lands at this hour, especially on another continent? Let me get to live chat. That's how I roll. Hi, Mike. I'm looking for locations of where you are viewing from. Kyle's in Hillsboro, Oregon. Rock Lover is from the Seattle Fault. Half Moon Bay, that's Ray. Marcia's in, Sonora, California. Some People Try in Marietta, Georgia. Ruth is in Yorkshire, UK. Letha Lee's in Marysville, Washington. Letha Lee, you're always early on these chats, I've noticed, in the live chat. Paul's from Glasgow, Scotland. I'm back a ways now. I'm slowing down the chat. I just want to make sure I can catch especially these exotic locations. Gondwana says hello from Aberdeen, Scotland. Mark's in South Wales, UK. Johnny is in Trondheim, Norway. I love this part, especially places far, far away. Ian is Sagi in Murrumbina. Ian, what is that? VIC. I should know what that is. That's Australia, right? But is that a, oh boy. Are there states in Australia? Are there provinces? Victoria, is that? Please forgive my ignorance. Stephen's in Abbotsford, British Columbia, Canada. Bo's in Denmark. Hans is in Netherlands. I'm still back a ways. Oh, there's Patrick. Good morning, Patrick. Age 10? Is that true, Patrick? You are 10 years old? Good morning to you. I'm glad you could join us for session B. Squaw Valley, California, that's David. Kim's in Maui. Oh my goodness, that sounds delightful. Liz and Dr. John are in Newport, Oregon, on the Oregon coast. John's in Greenwood, Indiana. I don't mean to ignore you, North Americans. What? But the Europeans, in particular, are really fun to see. Still back quite a ways. Ben is in the Netherlands. Dick is in the Netherlands, as usual. All right, let me come down to live. Retype if you feel like you'd like to connect. Tanner is in Austria. No, Tanner is reacting to Austria. Okay. So whoever you are in Austria, welcome. Arlington, Texas. Vancouver, Washington. Southwestern Georgia. Forks, Washington. Heard of it. Phil, not to be left out, says his ancestors were from Europe. Thanks for playing, Phil. Pueblo, Colorado. Black Hills of South Dakota. Mana is in England, UK. Peterborough, Ontario. Hi, Kevin. Dennis in Ottawa, Canada. So you're saying 5 by 5. So the mic is doing just fine. Good. Gordon's in Glasgow, Scotland. He's a regular. Carolyn, oh boy. Ian Zarot, Canaries. I need some help there. That sounds exotic. Is it? I thought I was worldly, but sometimes I read some of these locations and I'm like, oh, I guess I'm straight off the farm from Wisconsin. I don't know where some of these places are. I should. I apologize. Andrew says, good evening from the Yorkshire Permian Limestone in the United Kingdom. C. Carter is in France. Hello from France. Hello from the United States of America. Great to have you. Elaine reports that someone from Athens, Greece is checking in. Okay, now we have all sorts of reports, rumors. Gabriola Island in British Columbia, Julie, I think your location might be important to us at some point this winter. At least I recognize that name. Canaries are off of Northwest Africa. Okay, well, is that true then? The Canary person? Is somebody watching live from the Canary Islands? That would be really sweet. Not to belittle everybody else, but I'm getting greedy now. Eagle River, Alaska. Methow Valley. Hi, David. You're right up there in North Cascades. How are we doing? Yeah, we got plenty of time. Powell, greetings from Warsaw. Well, good morning from Ellensburg, Washington, USA. The Device 9 is feeling belittled. Well, it's bound to happen sooner or later. Okay, I got to email the guest. I'm having too much fun. Okay, give me a sec, would you please? You know who the guest is. I got to email Darrel. And as an older gentleman, let me narrate to myself what I'm doing. It helps me for whatever reason. Add guest. Copy link. Go to email. Paste the link. Use your Gmail to make sure it gets to Darrel and send. So I'll keep an eye in the green room, see if we have Darrel popping up in the next few minutes. I'm too comfortable this morning. I'm too comfortable. In other words, well, I'm too comfortable. It's too early in the alphabet to be comfortable with the technology. That's what I'm talking about. I see this little corner of my little table in the frame. It bothers me, but I need to move on. I got other things to talk about and think about. Let's say hi to a few more. Yes, it has been unseasonably cold here in Central Washington. Joel Gombiner from Seattle gave a nice talk yesterday in this room, and then we walked to Cornerstone Pizza, and we're like, oh my God, it is frigid out here. What is going on? It's a little early for this. And there's Darrel. Hey, Darrel, you're in the green room. Nice to see you. Thank you. Now, why did I think we're okay. What am I? Give me a second, viewers. Let me sure my mic is working within Melon. And when I go to my headphones, when we talk to, that's right. Okay. So I think we're good there. Okay, well, Darrel's in the green room. So Darrel, I've got I don't know. I had a few moments at the breakfast table. So I think probably 20 minutes at least with me, Darrel, before I bring you in for the first time. And then we'll just kind of roll with it from there. But I'm not coming to you immediately, I guess is my point. I was kind of hinting at that at some point. But at least 20 minutes. So once we get started. Still a little flustered why I heard that computer voice saying Darrel had arrived in the green room, but I think we're fine. I think we're okay. Yeah, let's say hi to a few more. This hot water's tasting wonderful, or feeling wonderful. I've got 3 layers on, as you can see. Little inside baseball. I forgot that a blue shirt. I just had a blue shirt on when I first turned the cameras on, and I was yellow. And I learned that lesson. I'd totally forgotten, but I had learned that lesson last winter, that when I wore a blue shirt, the cameras didn't like that blue shirt, and everything had a major yellowish tint. So I had this vest in my office, and I'm wearing it primarily to get rid of some of the blue. So I like the color right now, and I don't want to do it for you, but like if I just had that blue shirt, everything would turn very yellow. Who cares? Sacramento, California, good morning. Quartzsite, Arizona, Saber's still there. Saber's still there. Saber, right? Saber. Geologically speaking, you back from your trip, Todd? You back in SoCal now? A few more exotic locations, just feeling like I need another jolt or two. Again, I'm super greedy now, but if you're viewing from another continent, I'd love to see your location right now if I haven't read it already. Garrett points out that the globe is blue. Thank you, Garrett. There's Anders from Arup, Denmark. Good afternoon, good evening to you. Penticton, British Columbia. I guess that counts. Regine from France. Regine, you're a regular. I enjoy your comments that you leave as well. Thank you for that. Hard Rock Girl 58 is from the UK. Thank you. You know, now that I think of it, you could say whatever you want. You can say you're from Cameroon right now, and I would just read it and go, wow, hi, Cameroon. Like Christina, is she really in Kathmandu, Nepal? I hope you're telling us the truth, Christine. If you are, that is really cool. Hi to Nepal. Christina, just to test you, what time is it there? What time is it in Kathmandu right now? And are you on your phone or some wireless in a hotel or whatever, or do you live there? Getting too personal now. There's Aurelio from Valladolid, Spain. Aurelio is a regular. Omak, Washington. Honey Greg reports that Bob Seger did a great song about Kathmandu. Good to know. Okay. I need to start getting my head right. I have 2 minutes. I'm feeling reasonably comfortable. That won't last, but for the moment, I'm feeling like all is well, and so we are ready to go in 2 minutes. Thank you for joining us this morning. Hope you enjoy session B. Hot mic. Hot mic. Okay, you got chalkboards, use them. The chalkboards are not just for decoration. Use those chalkboards, especially the California triad thing. Just take your time to draw that out. That's a key part of today, whether Darrell wants to talk about it or not. I think I want to talk about it. California triad. Draw it, label it, keep it moving. That's what you're doing on the chalkboard. You've got your number scale that the viewers are looking at right now. Use that, explain it, and don't forget to use your little half sheet of paper. The insular and intermontane, how are you going to do that? You're mostly going to use the laptop and the slides from Darrell's paper, but you also have that cartoon. Don't forget to use that cartoon. You are loose this morning. You are unstructured this morning. Just let it flow. Just let it flow. Just go with it. You don't actually know what you don't know what you're doing today. You don't have any idea how you're going to go for those first 20 minutes, but just trust yourself. You can do it. Just go to one idea to the next. Use your handouts that are laid out. And the laptop's going to be one of the last things you do before you go to Darrell. You're setting up Darrell. This is about Darrell. It's not about you. It's about Darrell. All right, you can do this. You can do it. I believe in you. Good morning, everybody from Ellensburg, Washington, USA. Welcome to session B, called Crucial Tests. I'm making up these titles as we go, but I'll try to explain what the title means. And Darrel Cowan is with us in the green room, and we'll be bringing him in, I'm guessing 20 minutes, maybe a half an hour if I really get rolling. But I'd like to set up Darrell. I'd like to dip back just a bit with our first session, session A, which was Monday. And I'm reminding especially new people that I'm assuming that you are keeping up with the letters. Like today's not going to make total sense unless you see A before you see B. Those are the purposes of the letters. And speaking of the letters, let me give you a scheduling note right off the bat. So here we are in session B on Saturday morning, November 19th, 2022. And the next time that I see you all will be the night before Thanksgiving. In the States here, we have the Thanksgiving holiday on this Thursday, and it's a holiday weekend here, essentially. So Liz and I are heading down to Oregon to visit with some friends for a few days. So I will be with you here in this room Wednesday at 2 p.m. You remember that Wednesdays are at 2 p.m., but we're taking a brief break from our routine, and then we'll be back at it for many weeks in a row. Wednesdays at 2 p.m., Saturdays at 9 a.m. Pacific time. I think I should announce right now, before I forget, the guest for C. The guest will be Basil Tikoff. So between A, B, and C, between Linda, Darrel, and Basil, I'm hoping to have this opening trilogy, these 3 shows, setting the tone for this alphabet series this winter. That's the hope. And by the time we come back after Thanksgiving, I don't know who D's guest will be, or E, or F, or G. I don't know what we're doing. But I think we'll be ready to get into some detail after Thanksgiving. In other words, starting with session D. So please keep in mind today, if you're really gung-ho and you've been waiting for this series for weeks and weeks, and you're like, get into it, let's get going, let's get into the guts. We're not going to do that till after Thanksgiving. That's my choice. That's my plan. I think we need 3 full shows to set up the narrative of what this is, why is this controversial, and some of the key players in that story. And I'm looking for a sheet now. Oh boy. Hang on, Patrick. Patrick's here. Hang on, Patrick. Oh, are you kidding? I don't have it. Here it is. So my scheme then for our first 3 shows, there's a nice symmetry to this. We were looking back to a 1972 paper which started this whole Baja BC discussion. It wasn't called Baja BC in 1972. And since Merle Beck is following, I got a lot of email comment from Merle after the show A. Merle's just not comfortable with his age being up to being with us live. So Linda kind of sat in for Merle essentially, but Merle Beck and Linda Nosen, we were looking carefully at least at the basic level with that paper. We'll come back to it, I'm sure. Today is we're basically celebrating the 25th anniversary of an important Baja BC paper written in 1997. That's Darrel Cowan, and that will be the focus. And that paper waits for you at nickzentner.com, not secure. And then, as I just announced, our 3rd and final tone-setting session, session C, which again is Wednesday at 2 p.m. Pacific, just a few days from now, Basil has a brand new paper, co-authored by Bernie Housen. And so we'll kind of, basically kind of frame this up 50 years ago, 25 years ago, today, and kind of look at where we've been and where we might be headed. Beheaded. And I say we, but I don't really mean we, because I want to vamp, I think, right off the bat off of a kind of a casual comment I made in session A. I watched the replay. I enjoyed seeing all your comments. Always learning, helpful to me to see what you're interested in and what you're confused by and what you're wanting to get into. But let me expand on this for just a second. This winter is not necessarily a Baja BC cheerleading session 100%. So what I did say in the last show is that I'm a teacher. I don't have research that is, major amounts of funding dollars to support my Baja BC work. That's absolutely untrue. I have no skin in the game. I have no horse in the race. I have no motives to convince you that this is right or wrong. I'm trying to do that in these first 3 letters, just letting you know that I'm just wanting to learn. I said that more than once in the last show. I just want to learn with you. But there is no motivation to kind of lump myself with all of the most extreme Baja BC people. You know what I want to do? I want to just go to it right away. What are these numbers? Improvisation number 7 already this morning. What are these numbers? Well, this summer, as I was visiting and filming in the field, I don't know how many of those videos you saw, and I was starting to kind of share my early ideas about this Baja BC series with field geologists who have either been intimately involved or not at all involved in the Baja BC work over the last 50 years. As we're, talking on the trail, Bob Miller in particular, was a long hike back to the cars from that Windy Pass thrust hike. I just started thinking out loud. You've hiked with people. You just start, just off the top of your head, whatever, just conversations about sports or politics or religion or the weather or whatever. But I wanted to get in, brainstorm a little bit with Bob Miller. And then I did this with others as well. And I basically said, I don't know how I want to do this Baja BC thing, Bob. But I don't think I want to have it be 100% like this is a thing. And everybody I bring on the show is a huge believer. So I came up with this weird approach, a number system. And that's what I'd like to start with you right now. 1 to 10, I'm talking to a geologist now. Hey, geologist who's been studying the North Cascades or Western North America, where are you on this scale of 1 to 10 with Baja BC? And here's what I mean. 1 on the scale means you are a fixist. And Linda in show A casually mentioned that term a couple times, fixist. If you're a fixist, that means you're not a fan of Baja BC. And Baja BC, as we'll see a little bit more clearly today, is talking about up to 3,000 kilometers of northward movement of a hell of a lot of rock. Sorry, Patrick. A hell of a lot of rock moving 3,000 kilometers northward up the western margin of the American Cordillera. If you're number 1 on the scale from 1 to 10, you're not into that at all. What's the 10 of the 10 on the scale? That's a mobilist. Didn't budget my space very well. Let's try it again. Mobilist. 10. So there's this 1 to 10 scale. If you're 10, you want 3,000 kilometers of movement up the coast, and you love all the evidence for that. Fully embrace it. You are a Baja BC person to the extreme. If you're 1, you don't want any northward motion. But it is a scale from 1 to 10. And I think I can already anticipate what your question to me might be. Where am I on the scale? I think I'm an 8.5. But I'm open. I'm open to slide downwards or up on the scale. I don't know, maybe by mid-February when we're to X, Y, and Z on this scale, maybe I'll be up to a 9.5. Maybe I'll be down to a 7. I reserve the right to be fluid, and I hope that you would be willing to open your mind as well as these geologists talk about the evidence that they've had. And we will get into the nitty-gritty. But I'm perfectly willing to slide myself a little bit on either side of 8.5. And maybe you would be willing to slide a little bit too. I think that would be the healthiest way to do this. I see numbers here, so people are already timing. Oh, we got 11s in here. Okay, all right. So to expand on that, I had a little tease for you before we quit last time. Do you remember? I had 2 musical instruments that I did not explain. I kind of like it, but also I kind of don't. I'll do it anyway. I've already mentioned it. Accordion. And cymbals, a percussionist using cymbals in a symphony orchestra. To me, if you're a fixist, accordion. You are only thinking east-west. And you'll see these maps in a second. If you're a fixist person, you are acknowledging that there is plate tectonic movement, and you're acknowledging that there's some exotic terrains in the Pacific Northwest that have an oceanic origin, but you're just looking west out to the ocean to find those terrains, and you're bringing them in. And they're colliding. And we're squeezing the accordion, compressional. Between 100 million years ago and 53 million years ago, we're having a compressional squeezing of the squeeze box. You want squeeze box instead of accordion? Fine. And then as we learned last winter, across much of the American West, at about 53 million years ago, I guess we'll have some debate about that number, but at least in the Rockies, 53 million years ago, we suddenly start to pull the accordion back out and we extend the crust, and that's the crazy Eocene. Those are the metamorphic core complexes and the plutons and the gold and the silver and all that jazz. But if you view it from a fixist point of view, if you're number one on the scale, you are only willing to think as an accordion, east-west, compression, extension. You see what I'm saying? Now, if you're way over here as a mobilist, you're acknowledging that there's compression and extension. Again, the rough numbers are you begin compression in a major way. Well, I guess there's problems with this, but in my thinking right now, 100 million years ago, we start to compress. Even if you're up here, you're compressing, so you're fine with an accordion. And then the accordion starts to be pulled apart 53 million years ago in the Pacific Northwest, or at least Idaho and Montana. But if you're a cymbal player, if you're a mobilist player, you're not just thinking east-west. You're thinking cymbals, compression, extension, oblique cymbals. In 5th grade band, I was a percussionist. I had noodle spaghetti arms. I could barely lift these big cymbals in the big band performance with my parents and my sisters in the audience, you know. And if you've ever played cymbals and you're a young person, you're like supposed to like sometimes like go John Philip Sousa, those freaking things get stuck together, and then you're like wobbling around. You drop one, you split your thigh open. Okay, I'm a little dramatic this morning, but I have personal experience with cymbals. I also have personal experience with accordions, believe it or not. I'm Swiss German, so I was forced to play the accordion when I was young. Also unwieldy and huge. But enough about me. I'm setting up Darrel. The cymbal idea and the oblique nature. And you see what I'm doing with this cymbal. To get a good sound on the cymbal, I hit that cymbal and I don't get them stuck. I run it up the side. I make a nice cymbal crash sound, but and I'm doing this correctly, aren't I? For you? I might back away from that, but I kind of like it at the moment. So those are the two extremes. And to finish my opening thought here, believe it or not, after 14 minutes of this, settle in, Darrel. Come on now. I don't want to just have tens joining us. I don't want to just have nines and tens. I'm hoping to at least get a few fives and sixes, and I guess possibly a one or a two, although I don't know how many of those visits we will have. But if the tone is set properly, I think there's a way to do it where everybody can get something out of it, and it cannot be this ugly confrontational thing. Okay, that's what I wanted to say there. Oh, no, I'll say one more thing. Sorry. So I'll do it with the visuals. Okay? Use the chalkboard. No, I will do it. This is going away. We're going to talk about the California Triad in just a second. We're also going to get into this business of insular superterrain briefly, intermontane superterrain briefly, and we'll expand on it with Darrel. So this is going away. I think I want to add one more visual to what I just did with the accordion on one end and the cymbals on the other. So if you're a fixist, remember that so far the key part of our discussion is the Mount Stewart Pluton, magmas between 96 and 91 million years old, with an paleomagnetic signature that does not fit, that does not make sense with other Cretaceous Plutons further east in Cratonic North America. But what I want to do with this quick little map is that if we are, you remember the 1 to 10? It's not just Mount Stewart from show A, it's also Mount Stewart, which is invading both the Chewaucam schist and the Ingalls ophiolite and the Windy Pass thrust. And Merle Beck has confessed recently that watching stuff, some of these programs about the Ingalls and the Chewaucam schist and the Windy Pass thrust, he said, I had no knowledge of that stuff when I was doing my work 50 years ago, maybe even 40 or 30 years ago. He says, I was just viewing these Plutons themselves. And he likes the point, Merle does, and I guess Darrel and others will as well, that if we're invading the Stewart granitic material into these older oceanic rocks, then we need to visualize all three of these guys being moved if you're a mobilist. So if you're 1 on the scale, here's where this stuff is today. Mount Stewart and these other 2 rocks, right? Just north of Ellensburg, that's where these guys are. I guess if you're number 1 on the scale, that's the end of the story. And that these 2 guys came from offshore and got added, and then the Stewart Pluton came up right at this latitude, 47.5 degrees north. That's where it is. That's number 1. You're a fixist. You're an accordion player. Here's the accordion. Now are you seeing it if you didn't before? But what if you're a 2.5 on the scale or a 3 on the scale? You know what I'm talking about now. Then you're comfortable with the Stewart Pluton and these other rocks being in northern Oregon. And then they get moved a little bit. Maybe 100 kilometers, maybe 200 kilometers. Maybe you are a number 3.5 or a 4 on this scale of 1 to 10. You're a little bit more away from the true fixist. And now you're liking rocks that are down in Northern California and having them be moved up here. We're going to get into the evidence in letters coming down the road that we do have physical mapped evidence like this, that we can take our 3 buddies. Pink is Mount Stewart, green is Ingalls, gray is Chewaucam, and up in British Columbia, there's the same 3 guys. So they've been offset on a fault. Let's not get into it. Is this an example of a strike-slip fault or not? Here's some geologists, I'm not sure about Darrel, but some geologists that want the ophiolite that's here, that Mount Stewart invaded, dated at 162 million years ago. And they see, many of these papers, Jamie McDonald, Greg Harper, others, see a perfect match with the Josephine ophiolite. Rare rocks, dated exactly the same, apparently other similarities. Again, I don't think today we're getting into the pros and cons of matching these perfectly, but this is the kind of thinking we're starting to realize we have if we start dealing with these exotic terrains. So I think if you're a 3 or a 4 on the scale, you're willing to move Wrangellia from Northern California up to its present location in British Columbia. The crystalline core, which is now in the North Cascades, you bring them back down. This is from a show where we were looking at mapped strike-slip faults in the Pacific Northwest, strike-slip faults that we know. And we know those rocks had to be originally further south. I think if you're 1 on the scale, you just don't even think about it. I'm not even sure you're really looking at these faults and thinking carefully. You're just going, no. It's just easiest to think of the accordion. I don't want to think about anything else. That's my take. Now, if we really get a 1 on the show, I suppose they'll help me see that it's more than that. But I almost wonder if you're 1 on the scale of 1 to 10 and you're the most extreme fixist, isn't it more like it's just easier not to think about this stuff? Is that what it is? Okay. Seems like I'm switching gears, but I don't think I am. Let's go down to California, which is not on this map. And let's quickly, talking to myself, let's quickly draw something called the California Triad. Ready, go. The state of California, here's a map of California. San Francisco, Los Angeles, can be split into 3 regions: the Coast Range, the Great Valley, and the Sierra Nevada Range in Eastern California. These 3 things suddenly stop in Northern California. We're not bringing this into Oregon. But south of Cape Mendocino, we have these 3 features called the California Triad. But this is just geography. A coast range, and then it's, Central Valley of California, very flat, and then the Sierra Nevada Mountains to the east. But what is the geology that explains these 3 things in California? He goes to a cross-section. And I'm choosing to draw it out for some reason. I don't even remember why. I could just show you a quick sketch, but I don't know. Sometimes it's pleasing just to hear a clickety-clack of the chalkboard, I guess. So the Coast Range of California is this thing. And geologically, this is known as the Franciscan complex, a subduction complex or an accretionary wedge. The result, most everybody agrees with this, I think, that we're scraping off downgoing sediments. We're taking slices of material of the ocean floor. It's basically a garbage pile of material that has been scraped off of a downgoing oceanic plate. Yes, this is eastward subduction. This is an oceanic plate that's subducting, that's diving beneath California to the east. This is a cross-section, east over here, west over here. There's other geology that Darrel will talk about because this was his PhD thesis, his PhD dissertation on the Franciscan back in the 1960s that tell us about an eastward subducting oceanic plate. Not going to name the plate. Then there's a Great Valley sequence. Then here's the Sierra that originally were volcanoes. Those are plumes of steam. So there was a volcanic arc when we had eastward subduction beneath California to create large volumes, it's an understatement, huge volumes of plutonic material, magmas generated above this subduction zone, just like in the Cascades today. But back at this time, and this is not today now, this is back sometime back, we had a volcanic arc fed by an eastward subducting oceanic plate, and the magmas that have turned to stone now are the beautiful granitic rocks of the Sierra Nevada. John Muir Trail, Yosemite, El Capitan, El Half Dome, Kings Canyon, Sequoia, all that beautiful granite, quote unquote, is the remnant of this amazing eastward subducting plate. Major point. I need a dip. No, I don't. Darrel's going to correct me probably, but what I want to do is give you a basic message. Should have brought my red chalk for that. This is big. First major message is that the generation of magma in the Sierra Nevada range shuts off 85 million years ago. Please remember that. That's a big message today, maybe the biggest message today. There is a major shutoff of the volcanoes in Eastern California, and therefore we remove the heat from the magma system and we solidify the magma for the last time 85 million years ago. And apparently, going back to 120 million years ago, there was just continuous magma generation, maybe some pulses here and there, but you get the idea that it's a long-lived, set-up, eastward subducting oceanic plate beneath California making the Franciscan complex and simultaneously making all these magmas and volcanic events in today's Sierra Nevada range. Why did this thing shut off 85 million years ago? Why? There must have been some sort of major plate tectonic change. What are the dates for Baja BC again? The most conventional way to explain Baja BC, which is moving our guys north, and if you're above a 6 or a 7 on the scale of 1 to 10, and you're more of a cymbal player than you are an accordion player, you want this to start moving north, Mount Stewart, you want it to start moving north 85 million years ago. This is the key moment of this morning, which I will continue to elaborate upon with Darrel. You can't do both at the same time, I don't think. You can't have an accordion with eastward subducting ocean plate at the same time that you're moving things north. It just doesn't work. So you're forced to make a choice. And yes, if you recall, the conventional message about building the Rocky Mountains off the edge of the chalkboard here is the result of taking this steeply dipping ocean plate and shallowing it out and continuing with your subduction of the oceanic plate. The accordion continues, according to Bill Dickinson and others. So now we're into the Rocky Mountains and having another reason to not be wild about playing cymbals. Because you can't play cymbals at the same time that you subduct a major oceanic plate, known as the Farallon Plate. So this business about did eastward subduction ever happen, almost everybody agrees, even if you're a 10 on the scale, that this was a thing for quite a while. And who better to go to than Darrel for that? But this shuts off at 85 million years ago, apparently. And I'm confident that Basil Tikoff next Wednesday will be giving us the same basic message about the important shutoff of the Sierra. I'm going to go to the laptop really quickly to set up Darrel, and then Darrel, I'm coming to you in hopefully less than 10 minutes. Oh, screensaver. Okay. So here you are on the other camera. And you know how to get to this. This is nickzentner.com. In the upper right-hand corner, you click on the word Baja, and we're reading scientific papers together. And there are 2 from the early 70s. That was session A. Here we are with crucial tests, that's my label, for Darrel's very important Baja BC paper 25 years ago. We click on it, it looks like this. It's got key maps that look like this, and that's what I want to spend the next final few minutes setting up Darrel. And we might come back to these as we chat with Darrel. But I screen grabbed some of them over bacon and eggs this morning, and I want to just highlight a few of these. So here's your backcountry Gary photo of the morning from the San Juan Islands and some of his yellow labels. More coming on that, possibly today. I remind you that there are 2 interviews with Merle Beck waiting for you on YouTube. This one filmed 2 years ago. This one filmed this past August. There's also 3 videos waiting for you on YouTube featuring today's guest. Darrel Cowan in a purple hat. I think this is the first time I met you, Darrel, in your backyard during the heart of the lockdown in the summer of 2020. Darrel Cowan in that same purple hat, I presume, this past summer with Backcountry Gary spending a very memorable couple of days up by Mount Baker looking at all sorts of exotic terrain. That's a long video waiting for you if you haven't seen them. And here's a Backcountry Gary photo of Darrel next to a big block of yellow aster, the Belpass Milan, that Darrel was particularly excited about. And I was learning a lot in person. That purple hat again. I hope do you have more than one purple hat, Gary, or Darrel? That's our first question, I think. Purple again. So this is just last month, seems like forever ago, where Darrell and I took a ferry out to San Juan Island at Limekiln Point, and I continued to learn from Darrell. So there's plenty in video form waiting for you. But finally, we're to the guts of the matter in the 1997 paper, and we will continue to take our time with this as we visit with Darrell in just a second. But what I've chosen to do this morning is put a red dot with a black circle for Mount Stewart, the Mount Stewart Pluton and friends, that in today's map, on today's map, the brown is the intermontane, the yellow and the orange are the insular superterranes. We'll get into it more if you're new to this. But what I really want to emphasize is here, this blue, green, and red are the California Triad. And then these are other batholiths further south. Let's move on. If you're a number 1 on the Fixest scale, then here's the California Triad, and the insular superterrane, the intermontane superterrane, and Mount Stewart are right up where they are today. They formed up here. They got accreted up here if you're a number 1 accordion player on the 1 to 10 scale. But if we swing to the other end of the scale, here's Darrell in the 1997 paper saying, what if we have the California Triad not doing much, but what if we have Mount Stewart and much of the insular superterrane south of the California Triad? And then we somehow have to get that insular superterrane with Mount Stewart as the caboose. It needs to swim north and completely avoid the California Triad 80 million years ago, 70 million years ago, 60 million years ago, today. You want to do it again? These are famous maps presented by Darrell in cartoon form, just to get the point across. This is what you're looking at is pretty much a 10 out of 10 on the scale. You want a lot of movement north. One more time. 85 million years ago, Mount Stewart is at the tail end of this monster block called the insular superterrane, and this yellow stuff is a bunch of crunched material between the 2 superterranes, I might add. And in cartoon form, there's one major fault, the Baja BC fault, which we can elaborate on with Darrell. Last slide. Darrell, I saw this morning and almost choked on my bacon. I don't know if you remember this, Darrell, but you've got the Mount Stewart Pluton. And I'm like, wait, is that an error? Isn't Mount Stewart Pluton 96 to 91 million year old magma? But you're not saying magma, you're saying magnetization age. I'm curious if we can talk about why you're listing the magnetization so far younger than the Mount Stewart Pluton itself. Okay, wide camera, headphones. Darrell, I'm coming to you. I haven't even bothered to see if we're functional or just hoping for the best. Battery 100%. Connected to small lappy. Okay, hang on. Hang on. Turning off Bluetooth on the small laptop. That's why I heard this problem. Darrell, give me another 2 minutes. I need to be connected by Bluetooth to the big laptop. Daddy did it. Darrel Cowan. Good morning, young man. How are you today?
I've got the purple hat on. I sleep in it, by the way. How's the sound? Okay?
Your sound is great, and
Okay,
everything is perfect.
Good.
And I'm very excited to chat with you. Can we start? And then we'll go wherever you want, Darrel. But can we start with your days at Stanford University and working on the Franciscan? What years were those? And were you thinking Baja BC at all back in the 1960s?
God, no. No, I was there as a PhD student from September, 67 until November 71. And my supervisor was Bill Dickinson, but I also had Ben Page, Bob Compton, the real field geology Stanford faculty on my committee. And I chose to work in the Franciscan assemblage, we called it. And when I started, remember, no plate tectonics. We didn't know what it was. And but it was interesting. It had these high pressure rocks in them. And then while I was there working on this field project, fortuitously, all of a sudden we understood, thanks to a conference in 1969, there are hallmarks of plate convergence: subduction complexes, forearc basins, batholithic belts, and just like that, the California Triad, which I call it, I don't know if others did, we understood why it was there. But we're very California centric. You know, we were only thinking, well, this is California, but of course there's the Peninsula Ranges batholith, that's subduction related all over the globe. But we didn't think anything about Pacific Northwest geology or how this might relate up and down the coast.
And before we go there, this is excellent. You were working closely with Dickinson. Was he thinking about the Rockies and that flat slab thing even back when you were at Stanford?
I don't. He probably was. I mean, he was. He had real scope, and not long after that, he and Walt Snyder wrote a paper about the flat slab. But I think he was mostly interested in. He was a sedimentary petrologist and mostly interested in how the forearc basin could record the evolution of the magmatic arc as it got eroded and shed debris into there. So he wasn't, but I mean, he thought about everything. And I don't think we were at the point where we could, not long after that, we learned about Kula, Farallon, triple junctions, but I think it was really focused on just the signature of plate convergence, which, boom, there it is, the triad.
Well, this is, okay, so we're now into the early 70s. You're about to move up to Seattle to start teaching at the UW in 1974.
Yes.
Do you remember being aware of Merle Beck or Linda Nosen as you were arriving, or is that much later that you start?
I really don't know if I was aware of that paper. I mean, it was published in 1971, I think. But what I did become aware of is that the geology in the Pacific Northwest is very different from California. Number one, there's no California Triad. I think that made a big impact on my thinking about the Pacific Northwest. I began to wonder, well, why is it so different up here from what we learned in California? And to be honest, not much had been published on Pacific Northwest geology back in, when I got there in the early 70s. So yeah, I was learning, and then I did become aware of paleomagnetic data, because it wasn't just Beck and Nosen, but Ted Irving and his group were publishing. Merle was publishing other papers, and so that had to have an impact on me. I mean, maybe it moved me over toward 10. I like that scale there, and I'm going to make a sociological comment about that in a minute. But the other thing is, we did work in the San Juan Islands and took field trips in the North Cascades. And I said, well, this isn't California. There's no triad, but some of the rocks here are very similar to what we have down south, not north. And the two particular units are the Shuxon metamorphic suite, now we call it Easton, but blue schist and blue schist rocks, and the Fidalgo ophiolite. And the Shuxon, if you look, well, these are naps. They're just flakes and naps that have been assembled in this thrust system. Where do we see other rocks like that? Not north. There's no Shuxon north of the 49th parallel, basically.
Right.
But we look south and we've got all this Franciscan stuff. And I thought, well, could that be a fragment of Franciscan? Excuse me, I have to take a sip of water. A little laryngitis here.
You're good. Oh, you sound better than when we tested a few days ago. So
I'm much better.
Let me take advantage of this for just a sec. So I don't.
Pardon me.
You're good. I don't want to derail you. I know where you're headed, but even at this part of the story, you're trained as a field geologist, and from my point of view, if you're a rocks person, if you're a boots on the ground person, if you're banging on rocks and mapping faults and everything, you're just not naturally inclined to even read or listen to this paleomagnetic literature. Why were you so open to that where many people just weren't?
Nick, I think, and I want to say something back to your scale of 1 to 10. And it's a sociological, somebody ought to write a book about this. But for example, the group at UW, graduate students, no other faculty, I mean, certainly not Peter Misch, he wasn't a 10. I don't think he was way off, maybe negative. But I think our group, we valued tectonics, which is the synthetic part of earth sciences that synthesizes a lot of information and data. And that could be anything. It could be paleomagnetics, it could be sedimentary petrology, paleobotany. And I think we were able to accommodate and show an interest in all kinds of data. And so we were open to paleomagnetic data, even though we didn't do paleomagnetics, we didn't do that at UW, but we saw the value in trying to understand larger tectonic issues.
Well, I'm going to cut you off again because to me, this is a crucial point. Like, it's like 2 strikes already for you personally. Number 1, you're a field geologist. Number 2, you're from California. So of anybody, you should be the person who's like resistant. Can I try one more time? Is it something about you personally that is more willing to be?
No, I think it's just like I think Basil reminded you about an earlier paper I wrote in 1994 in GSA Today, and I'd forgotten about that. I went back and looked at it. And there it is. And I think I kind of forgot about it because back in those days, GSA Today was published in tabloid form, like the Inquirer and the New York Post, and thought, well, maybe it didn't have the same legitimacy. But I read that and I looked at who I acknowledged, and it was Mark Brandon, John Garver, Paul Umhofer, Margie Russmore, and we were all there together. And this is 1994. They had all left, but they were graduate students together. And for some reason, I think it was just because of our scope or our interest in tectonics that we wanted to evaluate all kinds of information, not just boots on the ground. I mean, that's the best way I can put it. And
that's more satisfying to me, I have to say, because you were really into those grad students back in the 1980s. I'm sure they were bringing all sorts of stuff to you as well as you mentoring them. So if they were leaning into the paleomag as much or maybe even more than you, I don't know, and I'm writing your own narrative, but to me that makes a little bit more sense, that there's a lot of experimentation and you're publishing eventually with those former grad students together.
I think you made a good point that it was symbiotic. I mean, I was their supervisor of record, but they taught me a lot. And remember that they didn't just leave this topic. Paul Umhofer went and worked with Sandra Wild and wrote a really important paper, in the mid-2000s, with a different aspect, not paleomag, but said, what if we just restore the slip on the faults that we know? We can come up with an estimate that's more modest, yes, about 900 kilometers, I think, or maybe maybe 650, maybe 1,000. I think it was 1,000 kilometers. So they kept going. Margie's published on the Coast Mountains, and of course, Mark Brandon and Jay Ague looked at Mount Stewart and tried to figure out had it been tilted. So all of us kept going. But I think it's the just the basic level of interest in tectonics and how to use that to synthesize large scale geology.
Thank
I
you.
think that's the best way I can put it. And it happened here at UW.
Yes.
I could cite other departments where they were down about 1 or 2, and they had field geologists, paleomagnetic people, but weren't, why did the novelty of this hypothesis grab us, and we didn't just let it go?
Okay, well, wherever you want to go from here, I'm feeling better that I can kind of see that transition with you. So thank you.
Well, I think also maybe in one of our discussions together, you've asked me why did we write the 1997 paper? And I'm going to back up and say, why did I write the 1994 paper and the GSA Today paper? And I think it was because all the paleomagnetic data had been published, and we had the idea that it was 2,000, 3,000, and I thought, it's time to show a geological map with colors on it and geology that Californians, especially Californians, would know. That was the 94 paper, actually, which was a precursor to what you're showing there.
Okay.
And in the 94 paper, it's a cartoon. It just shows the general idea, but it does show the California triad. And I think, well, now, geologists can see what this really means if you are going to be fixist or mobilist. And it's different. It's radical. I mean, it's a lot different than just seeing numbers on the page about latitude and displacement. And then I remember getting together with Mark Brandon and John Garber. And if I say I or me, or I really mean our and we, because it was a joint effort. And I remember at some point somebody said, we've got to get this off the back burner. This whole Baja BC thing, for geologists, it's just not getting any traction. It doesn't have any legs. And so let's put it out again and be a little bit more specific. And the last sentence in that GSA Today paper, I wrote it down. I said, maybe geologists should design specific tests to rule out 1 or 2, or A or B. And so that's basically what we did in the 97 paper. We went through the whole thing, set it up like you did this morning, and here's Intermontane, but we said, what are things that we could do to rule out, not we, but the community, one or the other? All scientists know that you can always support a hypothesis with corroborating data if you want to, but it's what we really need to do in some cases is set up an alternative. This is Chamberlain back in 1910 or something, and set up an alternative. And how do we choose between what apparently are 2 explanations of observational data?
And
so
it was your choice with that 97 paper to not focus on the paleomag, but to use these other things with your tests?
Yeah, I think paleomag was well known, and you showed that table, the age of the magnetization, and you've caught me flat-footed here. I don't know why we put that in. It had to be out of another paper. I mean, I think we gave references to there, and in those days it might have been if there was still some debate about the cooling ages of the Mount Stewart or remagnetization. I really don't know, but
it'd be fun to follow up on that.
I'm gonna channel Merle and say the data are impeccable. I mean, in spite of repeated attempts to shoot them down, I think they stand. So I think back to what you'd asked about, I mean, setting up tests that geologists could do, not paleomagnetic people. I mean,
Right.
they've looked at those data. They've gone through all the paleomagnetic tests. So what good old geology could people do that would maybe provide a yes or no answer to these hypotheses?
Because by 1997, you and your grad students had already seen enough of the reaction to the paleomag work where people were just not even reading the papers. And
Yeah.
so your approach is like, okay, well, I'm not going to do anything meaningful with many of these folks if I just do another paleomag thing. So
Geology.
I think you addressed, you addressed it in the paper. Yeah.
We wrote it for geologists. I mean, if I just briefly looked at the 4 tests, one, and interestingly, I think this might have been John Garver's input, but detrital zircons. We said let's look at the provenance of sediments in these basins. And by that time, thanks to Paul Hoffman and a lot of work, we knew where the provinces of Precambrian basement rocks were: North America, 2.5 billion, Archean up by Wyoming, and then down into Mojave, Yavapai, 1.4 billion. So there's maybe if you use those as kind of the sources, latitudinally different, you could find out where this thing was. And I didn't go look at when did detrital zircons become the thing. I mean, they are now, but that was pretty early. And I think right away, Brian Mahoney and I think it was Peter Mustard picked up on this and wrote a paper in Geology where they did follow that thread. But we might have said something about paleobotany and I think we had 4 things that geology could do that might have provided crucial tests.
And I think that's how, at least I'm thinking out loud now, but maybe much of December is looking at the detrital zircon, looking at some of the, just generally. So your paper, your 1997 paper that we're talking about today is kind of like a challenge to the geologists.
Yeah.
Can you follow through on some of this, please?
Well, we didn't. I don't think we cited any detrital zircon data in that paper.
Okay.
It's just kind of, here are 4, 1, 2, 3, 4, and what you might do. But other workers, not only right away, Brian Mahoney and I think it was Peter Mustard pick up on this, but now there's a lot of activity, and there was kind of a quiet period there where nobody was addressing this, and then Trevor Dumitru wrote a really important paper, don't remember the date, where he identified a source area in Idaho, Nices, in the Salmon River, that he thinks provided a very distinctive doublet of ages of Precambrian zircons, not only Southern California, but to the Swakane Gneiss in the Cascades and the Yakutat block. And that might have reinvigorated the use of detrital zircons in trying to address these latitudinal displacements. But we didn't, I don't do that. John Garver does, right, but I don't. Right. So we really didn't, we kind of threw it as a challenge and said, here are things that might work. And I think what was picked up was the detrital zircon work. What we didn't know about, I think, is something else important, and that's the whole Siglock, Mahallanook, Clinet, thinking about tomography and the slabs that are dripping down into the mantle and how that might give us a glimpse at the plate configuration. So yeah, it was a challenge. I mean, that's why we did it. Get it? maybe provoke people, not the paleomagnetic people, but provoke the
No.
geologists.
Well, yeah, to feed off of that. So here's you in the 97 paper. Most geologists have already concluded the Baja BC hypothesis, based solely on paleomag, has a negligible probability of being true. I mean, you're basically saying, okay, you guys are not even looking at this stuff, so let's go a different route. But I know maybe viewers, we're going to give you a chance to certainly ask a bunch of questions of Darrel, but maybe Darrel, you did have some thoughts about paleomag. Did you want to just kind of give a general message about why you go ahead, however you want to do it?
No, I would. I think, listening to the show last time with Linda and looking at the live feed. And by the way, I can't see the live feed here because I'm on Chrome, but, and that would distract me anyway. But I saw a lot of questions about what is paleomagnetism, old magnetism? Why is it important? And can I just take another hour? No, I'm kidding. No,
I took a long time. You take the time you need.
A few minutes and explain how valuable it can be. And I'm going to do this quickly, but number one, on Earth, we are living in a magnetic field. The Earth has a magnetic field. You don't feel it, but it's here. And an interesting thing about that, think of the magnetic field as a vector, force vector. I'm going to use a baseball. I got it at a Mariners game. And the orientation of that vector at the poles is directly down. So it's pointing down, that force. But as you move toward the equator, it becomes horizontal, parallel to the Earth's surface. And the orientation of that force vector is a simple trigonometric function of latitude. So the idea is that if rocks can record the orientation of that magnetic force field back in time, that's old magnetism, you might be able to figure out where the rocks were latitudinally on the Earth's surface. Doesn't work longitudinally, but it does latitudinally. Point two, paleomagneticists are experts at second point is that igneous rocks, when they cool through about 550 Celsius, the magnetic minerals can record the orientation of the Earth's magnetic field, magnetite and ilmenite, and they freeze it in the rock. Sediments are gooey and sloppy, and little minerals can align themselves or orient themselves parallel to that magnetic field, and then the sediments consolidate and hard. So paleomagneticists realized a long time ago, we can go out and if we can collect samples of igneous rocks, basalt especially, plutons, sedimentary rocks, and we know the age of that magnetization, we might be able to get latitude. I mean, it's really, I'm sorry, Merle and all paleomagnet, it's really that simple, but that's why it's so important. It gives us information about latitude that only paleobiological data or now maybe detrital zircons could give us. But it's so well known, and it was number one in figuring out where the latitude of these rocks are. Now, they measure these things like Linda did, and there are all kinds of tests. They can't be remagnetized. But what I think impressed us is that out of all these paleomagnetic studies in the Northwest Cordillera, there are a few that are really solid and have been attacked and looked at, and no one has been able to refute them on some geophysical basis. So that I think impressed us, that these are certainly Ted Irving. I think Ted said one time, one data point is all you need. I mean, he could be flippant like that, and he was an expert. But I think that potential of paleomagnetic work, old magnetism, to determine latitude was really important. I think
what's your take on why non-paleomag people are not valuing the data?
I really don't know. I think, part of it, I think, is like you said, I just don't want to deal with it. I mean, there are times when I've said I'm a number 10 or maybe 10 and a half. I just don't want to think about Baja BC anymore. I'm working on rocks in Death Valley. It don't have anything to do with Baja BC, but I think part of it is just, I don't want to learn about it and I don't understand it. But others, I think, just, I don't know. It's like me saying, I don't believe uranium lead isotopic dating because there's something wrong. I don't know what it is, but these numbers just can't be right. I mean, that's
Yeah.
that's an arrogant, flippant statement, but I truly don't know.
How about this for wrapping up you directly, and then we'll go to the viewers, unless you had a lot. Did you?
No, I think I touched on why I wrote the 94 paper and why we wrote the 97 paper. I didn't explain why our group at University of Washington, a group of tectonically oriented students, was so amenable to looking at all kinds of different information and not letting something that could be really important just die. And I think I've commented about that.
Okay, well, if you're willing, before we go to the viewers, and this is more of a personal question, but you can pass if you want. Like, is part of the reason that you got away from Baja BC because it got too confrontational and you were just tired of being the Baja BC person against all these other things? Did you have some uncomfortable interactions or something that eventually said, screw it, I'm just going to go do something less controversial?
No, I don't. I think it was, that's a good question. It was probably because, well, I'm not going to do paleomagnetics. I'm not going to do detrital zircons. I'm not going to go look for leaf fossils, that kind of thing, which the rest of the group did, not paleomagnetics. So it's like, yeah, what can I contribute here beyond thinking about the geology, which I still do, by the way. One of the other crucial tests was, can we find, I mentioned that I thought some of these rock units came from the south, and can we figure out where they actually came from along the continental margin of North America? Yeah, I thought there wasn't much I could do, and I also sensed that the whole idea wasn't getting much traction. I think it went to sleep for a while until the detrital zircon data came back out. Or Paul and Sandra Wild published their paper, and a little more paleomagnetic work, but it did kind of go to sleep. I think put it back on the back burner. So
that drowsy time, that sleepy time with Baja BC breakthroughs and publications, roughly that's like the 2000s.
Yeah, I think that's right. I think Umhofer and Wild was 2000, or Wild and Umhofer 2006, something like that. And then I think it came alive again with the detrital zircon work, which that's my recollection. But
well, this is Darrel. You're just so good. It's just so pleasant to visit with you, and you're always so clear.
I love doing this, but it's not. There's a lot of, like I said, sociology in here. Scientific sociology about how people distribute themselves on your scale.
Yeah. Okay, viewers, looks like we have some interesting spam. Hopefully that will disappear in the replay. It's time for some questions, and Darrel's flying blind, but I will be happy. So let's start. Spreading Ridge, John Nash. Hello, Darrel. To get an idea how far east the Cretaceous coast was, how far west did the Northern California terrains get bumped west via the Basin and Range extension? I'm going to try that again, unless you've got it. Darrel, to get an idea how far east the Cretaceous coast was, How far west did the Northern California terrains get bumped west via the Basin and Range extension? Do you have anything to say there?
Yeah, basin and range extension, we understand that pretty well. That's young. That's, largely 30 million years to going on today. So everything had already been put together. But he does raise an interesting point, and that is when we talk about where was Baja BC, where was Intermontane, where was Wrangellia, we want to know where it was with respect to North America. And so how do we know North America's moved? Everything's moving right now. North America's moving with respect to Antarctica, South America, that's plate tectonics. So we need to know where was North America during this critical time, 85 to 60, and that means where was the coastline? And this is what Bernie Hausen has gone back and reevaluated the paleomagnetic data for where North America was. So I'm going to make one other comment, and I think one of the big unknowns now that we need to make progress on, but it's going to be very, very difficult, is what were the plates? Where were the plate boundaries? You want to put Baja BC, Intermontane superterrain down south, 3,000 kilometers. It's difficult enough to know what were the plate configurations 50 million years ago. That's what Mike Eddy does. People are still working on that. So we really don't have a very good picture of where the plate boundaries were, but we do know, thanks to paleomagnetic work, where the coastline of North America was during that period. That's a long-winded answer, but it relates
that's
to,
great.
Yeah.
Thank you for the question, John. Kyle Roth, Darrel, do we have paleomag data from the Intermontane belt, and does it agree with the Mount Stewart magnetism?
We definitely have paleomagnetic data from the Intermontane, not we, but the community.
Yeah.
And it shows a very different configuration and movement history, that it was farther south by about 1,000 kilometers. It's in the paper, the 97 paper, 1,000 kilometers, and then moved northward. So it was farther south, distinct from the insular superterrain, which was much farther south, but then they've become juxtaposed thanks to this movement. And I think Basil might talk about this,
Yeah.
But we definitely have a movement picture for Intermontane terrain.
Excellent. Oh, Darrel, we have a question from Patrick, age 9. Darrel, so does this all hinge on whether or not people accept paleomag data? Is there anything else that can help conclusively prove the Baja BC theory by itself?
I think back to paleomagnetic data, if you are one or negative, and you, for some reason, you don't understand or you just cannot accept paleomagnetic data, then you won't be interested in any other further work on Baja, British Columbia, I think, because the hypothesis rests on paleomagnetic data. But maybe following up on Patrick's question, is there more field geology that can be done? I think there is. And I think reevaluating these mantle slabs and their configurations, if we could get a good age on them, we'll make some progress here. But if you cannot accept paleomagnetic data, and I don't know why, then you should just leave the topic. It's not going to be of interest to you from here on.
Very interesting. Let's keep going. Thomas asks, is there any data out there that is incompatible with Baja BC?
Yes, the Brian Mahoney and his group, who you know well, have looked at detrital zircon data, and they and also Dumitru did, I think, who looked at detrital zircon data, and they will make the point that they can derive the detrital zircons from Montana, basically, or Idaho. And therefore, they just came across in unknown river systems back, especially in the Nanaimo group. This is another important unit, Upper Cretaceous sediments that are deposited on Wrangellia and are part of Baja, British Columbia, that lots of people have looked at the detrital zircon population. So they did publish a paper and said, we think they just came right west. I'm
Yeah.
kind of summarizing their argument here,
Right.
but yeah, they think the detrital zircon data are not consistent with a southerly position. So people are still working on it. Yes.
Yes. You got a few more minutes? This is great. I want to go
Yeah.
for a few more. Okay.
Yeah. I can't see live chat, but I will look later.
There's a lot of good stuff. Backcountry Lindsay Malone asks, Darrel, do you know of any studies or papers that have responded directly to your 1997 paper?
Yeah, I think not long afterwards, maybe 98, Mahoney and Mustard, I think it was Peter Mustard at the Geological Survey of Canada, looked at detrital zircons, and even then said we can get those from Montana. I think some of the zircons they suggested came from the belt supergroup, Precambrian. They're Precambrian zircons. They're not. You don't need 70 million year zircons. You really need the Precambrian, so you can find out where in continental North America. Nobody's going to argue North America was not a continent. Where in continental North America you could have derived the zircon. So yeah, right away, I think in a year or two. And interestingly, Bernihausen and Merle Beck countered that and said, no, this is not a crucial test, and here's why. So there was a flurry of back and forth. We think this, no, we're going to reevaluate your data. And then we went to sleep. I think there was just a long time where nobody did much of anything.
Gary Ritchie asks, there must have been some major faults. Do we have evidence for them? This
is another reason I think geologists definitely might be on the low end of your numerical scale there, and no one has been able to find a San Andreas type Baja BC fault cutting through the Cordillera all the way up into Alaska. We have candidates for it, like the Pasayten Fault, that's debatable, the Cochire Zone through northern British Columbia. But I've always thought, what's the preservation potential of a fault that might have 3,000 kilometers of strike slip on it, given everything else that's happened in the Cordillera, basin and range extension, intrusion of Coast Range batholith, younger plutons. How long will the San Andreas Fault be preserved? It's only 5 million years old. We're trying to find something that's 80, 70 million years old. So it may be. This is why I get back to this point that we don't really have a good view of what the plates were and all the possible plate boundaries. But you look at the figures in Clinette and Siglock and others, and they've got plate boundaries in the Pacific, dipping all kinds of ways. And we're in an evolutionary situation about how to picture plates and name them back in a long time ago. So to me, it doesn't bother me. I'm a geologist, and I'd be really surprised if you could go out and find one fault from Alaska to California.
Yeah. How about two more? This is wonderful. David asks, are there other places in the world with displacements similar to Baja BC?
I I did a little work in Japan on the, it's called the Shimanto accretionary wedge. And, Japan has it's a beautiful island arc with a long history of convergence. And there are repetitions of units in Japan. I don't remember their names and everything. And I looked at this, and one idea is, well, you repeat the units by naps and thrusting, but they're also high angle faults. And I thought, well, maybe this is a way of slicing stuff up from farther to the south. And some paleomagnetic data is in support of displacements, let's say latitudinal displacements, but I had a distinguished geophysicist say, no way. They're just the data are whack. Don't worry. So I think the best place to look is Western North America. Gosh, we've got an example. This is why, we call it Baja British Columbia, because the thing moved like Baja California is doing right now.
Thank you. One last question.
Sure.
Oh, I'm getting the same question a few times from Mike Rod. Preservation of this fault, not very likely, but the fault would be in Mexico, not here, right? And another person asking, is it likely that it's one major fault or maybe a bunch of smaller faults that are acting together?
It would be, largely offshore, which is one problem, but it had to come onshore because now we see insular superterrain onshore and juxtaposed with intermontane superterrain. And that's where we look at faults like the Pasayten Fault and the coast shear zone. But in these cartoons, it was probably largely offshore, and it could have been, yes, a system. So we're just not able to draw a better, based on what we know paleomagnetically or geologically, a better set of figures that show what might have been. But there had to be major strike slip faulting.
Yes. Thank you very much for your time.
You're welcome.
All these wonderful answers, and the presentation I thought was perfect with what I was hoping to do today. And I know that you've been pretty good about being in the live chat. So even with your baseball. So I hope that you can continue with us, especially in the live chat. And it's just been an honor and a privilege to be with you again today, Darrel. So thank you so much.
I will see you Wednesday for sure. Yeah.
Okay. Sounds good. All right. Have a good day, Darrel.
Thanks. Bye.
Bye-bye. Darrel Cowan, University of Washington. He's in his late 70s, but he's still teaching every once in a while. This particular quarter, he's not teaching, but he mentioned to me that he could not join us for many of the crazy Eocene sessions last winter because he was teaching. So there's a goal for me to still be teaching in kind of a phased form for another 20 years. If he can do it, maybe I can do it too. What an inspirational guy. A couple final, just I guess, lots of nice thank yous to Darrel. That's nice to see. I don't know. Give me a second. Let's see if there's anything that I kind of was hoping to do with you that I just got sidetracked about. We're pretty late here, but yeah. So let's say that you're new to us and you did not see live streams 2 years ago when we were talking about all these exotic terrains. This is one way to summarize a bit of what we were doing, because I knew none of this 2 years ago, and I was going exotic terrain by exotic terrain up in British Columbia, Quinellia, Cache Creek, Stikenia, Rangelia, Alexander, all these names that were foreign to me until 2 years ago. And with Darrel's help and many others, I've been able to kind of learn, and we've been learning together. So if you're feeling like I'm over my head, I didn't get half of what was going on today, I guess I'm hoping to encourage you to stick with us. This is still, I don't know, what's the best way to say it? I think this is the best way to say it. Darrel and I emailed a little bit back and forth midweek after Darrel saw session A. And he said, here are some things. He wrote out a bunch of text in his email. Here's some things I want to say about Paleo Mag. And he said, it's maybe too much. And I think I replied, I think that's great. I think you should do it. I think some of the details that you're going to get into are maybe not going to be easy to follow for our viewers, and oftentimes not easy to follow for me. But I think that's okay. What I'm trying to say is that in these first 3 shows, we'll be kind of flirting with some of the details and some of the names of the places and the units and the workers and everything else. But it's okay if some of that washes, I'm talking to myself now, I think. It's okay if some of that washes over me and I don't know where the Carmax volcanics are. I don't know the Toyota and whatever. We're early in the series and just trying to complete this trilogy to start us. And we're midway through these 3 opening episodes. And I think you got the sense of when Baja BC work was kind of happening. And then, as Darrel mentioned more than once, things kind of went to sleep. And I didn't mention to him, but it seems like things are waking up again a little bit with a couple papers that have come out in the last year. And so that's kind of what we look to next. So when I finally hold this up, I'm not going to go back and do a bunch of individual terrains. That we don't have a whole alphabet to do that again. But I think I'm just kind of talking out loud with you now. I think I am going to be going back to some of these almost greatest hits of some of these insular and intermontane basics after Thanksgiving. Yeah, I think that's what I'm saying. Just decided right now, I think. Yeah, let's look at the calendar and follow through. I just ripped my calendar. Stupid. So session C, I've already announced at the beginning of this episode, our guest will be Basil Tikoff and a brand new paper that he has out with Bernie Housen. We'll take a break for Thanksgiving. And I think I've decided right now with you guys that at least 2, not sure, at least 2 of these episodes will be going back and doing some basics of the exotic terrains that I have already done over the last couple of years. I think I want to do that. I want to just kind of warm into this by doing some greatest hits of the last couple of alphabet series, which will remind some of us of some of the basic messages. It will remind me of some of the basic messages. I don't remember half of that stuff. And then less sure about this, but probably in December talking much about the detrital zircon, maybe waiting till after the new year to get into the details of Paleo Mag. Obviously, we need a whole bunch of letters on that. Not sure about that, but that's my thought. Okay, a toast to you. Here's to you for joining us live. I didn't even look. We've had, 800 people watching live on a Saturday? Here's to you. Thank you for joining us live. Here's to our guest, Dr. Darrel Cowan, University of Washington, has been teaching there since 1974. Thank you, Darrel, for your time, energy, and expertise. Here's to the health of your family and your friends, everyone in your community. Hope everything's going well for you. If you didn't catch it, I mentioned Paul Umhofer, who passed away tragically a year ago, about this time, unexpectedly. And it's Paul, who had a license plate like this, that is the inspiration for this from Kay in Seattle. If you didn't catch it, Paul Umhofer was one of the many graduate students that were supervised by Darrel Cowan. So as we go through the list of all these workers with important Baja BC papers, guess who was supervising all of that work? Darrel Cowan. I think it's time to end this live stream and brave the cold temperatures as I walk back home and hang out at home for the rest of the day, probably. Get caught up on some things. It's been a busy week here. So I say, with the Chihuahua schist, thank you. I love you. And goodbye from Ellensburg, Washington, USA. See you Wednesday at 2 p.m. Pacific time for session C with the University of Wisconsin Structural Geology and Tectonics Professor Basil Tikoff. Have a good weekend. Goodbye. End stream. See you later.